Financial modeling, topic 21, capital budgeting, section 4. We're going to evaluate investments with cost only. The first one we're going to look at, we're thinking about automating labor. We're going to buy a robot and replace some of our manufacturing labor. These savings in labor are expected to last the next 5 years until the product line is due for refurbishment. And that robot's going to be depreciated over 7 years, but sold at the end of year 5. So let's go to the spreadsheet, which is mostly done for you. So here you have, I'm going to buy a robot today for $500,000, and that robot's going to require some working capital of $10,000, which then is going to be replaced in year 5. That robot's going to have maintenance expense of $5,000 a year, but I'm going to take my after-tax maintenance expense by taking the OPEX of that $5,000 and multiplying times 1 minus the tax rate. I'm going to then take my depreciation tax shield. Since I'm going to depreciate this over 7 years, I'll take $500,000 divided by 7 and multiply times the tax rate to get the tax shield. And then I subtract my CapEx. At the end, I'm going to resell that robot for $50,000 after tax. It's actually $73,000 because according to the IRS, it was worth $142, and you sold it for $50, so you get actually a tax rebate or a tax shield on that. And these are my free cash flows. So I'm going to then calculate my NPV, but what I need first is just talk about this, how to deal with the savings. So right now, this would just be the costs of the robot, including its CapEx, OPEX, and depreciation, but the robot's going to save labor. The labor savings are going to be, it's going to be $50,000 a year, $150,000 a year. So I'm going to include labor savings as a revenue, but I need to take that after tax. So I'm going to multiply that times 1 minus the tax rate. So my after-tax savings is 112, and again, I'm treating it just like revenue. Now notice I get a number here, and in year 1, if I take my after-tax savings, you can think of that as revenue, my after-tax maintenance and my depreciation tax yield, I get 126.6. Now I could have done this the longer, a little more painful way that you might be more comfortable with. I'll treat the 150 like savings, or I'm sorry, like revenue. Subtract out the $50,000 of the OPEX, subtract out depreciation, get my EBIT, do EBIT after tax, and add back depreciation, and I get 126.6. But notice that's the same number as this. So by just treating the after-tax revenue, after-tax OPEX, and depreciation tax shield, it's just a short way of getting these free cash flows. And then I can calculate the NPV. Looks like negative $44,000. And my IRR, 11%, because this project you wanted a rate of return of 15%, and I only got 12, so it has a negative NPV. So I also calculated the payback period on this one. Notice the cumulative free cash flows. They turn positive in year 5, so we say the payback is 5 years. This is not a discounted payback because that would be not in this horizon. It never gets paid back. So let's talk about another possible investment. I need machine A or machine B. Both of them are required to run the business. However, machine A and machine B have different lives. We're going to calculate the NPVs of them, which I've already done for you in the spreadsheet, and then we're going to compute the effective annual cost, the EAC, to determine which is cheaper per period. So going to cost only here. I have machine A. That's going to cost me $100,000 a year, depreciated over 3 years with a $25 salvage. It's going to cost me $75 in OPEX per year, tax rate of 25%, discount rate of 10%, and no working capital. So I'll take my after-tax OPEX, my depreciation tax shield, the cost today, and the after-tax salvage. So these are my free cash flows. I'll do the same thing for machine B. Machine B has slightly different numbers and lasts for 5 years, but the same calculations. If I calculate the NPV of machine A, it's negative 205. The NPV of machine B is negative 260. Again, normally you say you don't accept a project with a negative NPV, but what I'm telling you is I need this machine to run my manufacturing line, so I'm not looking for a positive NPV. This would shut down my business. So I just need to choose between machine A and machine B, and it looks like machine A is the best if I just use NPV. However, just like we did in the example of the 2 light bulbs, those light bulbs that last forever and are really expensive sometimes are better than the ones that are cheap and last a short amount of time. So what I'm going to do is I'm going to convert these NPVs into EACs by doing the payment function. I'm going to put in my discount rate. I'll just anchor that. I'm going to put in the number of periods. For this one, it's going to be 3 periods. And for present value, I'm going to put in the NPV. So this project actually cost you about $82 a year. This project, if I switch this to a 5-year life, cost me $68 per year over 5 years versus $82 a year for 3 years. But on this one, I'd have to replace it. I'm assuming I'm going to have this machine. I'm going to need this machine to run my business for the next few years, or infinite period of time. So really, the cheapest one is machine B. So in this topic, we looked at evaluating investments that have only a cost.